So in this elementary algebra course, we solve different types of equations. Linear equations, with the example shown here, rational equations, which essentially is code word for fractional equations or equations with fractions, radical equations, an equation that contains a radical, and the last is quadratic equations, equations that have a degree of 2. Let's take a look at some examples of solving different types of equations. Here we have a linear equation. First, in this example, we will want to get the variable together. We have a couple options, but provided we maintain equality, either one of those options will work. In this example, let's subtract 3x from each side, which does result in the variable on one side of the equation. The focus then is to get the variable by itself, so to eliminate the positive 4, we'll subtract 4. Last, we will undo multiplication, since we want to have a coefficient of a positive 1 on our variable, by dividing both sides by 4, which results in a solution of x equal 1. Of course, we'd want to check this by replacing the variable with the value of 1 in the original equation to see that we do get a true statement. Here's another example of a linear equation. The priority here is to eliminate the parentheses. So using the distributive property, each term in the binomial will be multiplied by 2, resulting in a 10x minus 6 for a substitution of an equivalent value. Next, we have a variable on both sides of the equation. We want to get that on one side of the equation or the other. To maintain equality, we'll subtract 4x from each side, which results in the following equation. The goal then is to get x by itself. To undo a subtraction of 6, we'll add 6 to both sides. And last, to undo the multiplication, we'll divide both sides by 6, resulting in a solution of x equal 1/6. To check this, we would replace the variable with this value in the original equation, looking for a true statement. Here we have a rational equation. And rather than try to find a common denominator to simplify, we're going to eliminate the denominator. We're going to clear the fractions by multiplying every term by the least common denominator. We have denominators of 9x and 6 with the least common denominator of 18x that each of these denominators would go into. To maintain equality, we'll multiply both sides of the equation by 18x. On the left, we need to use distributive property so that each term is multiplied by 18x. After simplifying the multiplication, the denominators are gone, leaving us with 4 minus 15x is equal to 18x. We have the variable on both sides of the equation. Our next move is to get it on one side. We'll accomplish that by adding 15x to both sides. And last, to undo multiplication, we'll divide both sides by 33, the coefficient on x, to leave us with x with a positive coefficient of 1 equal to the value 4 over 33. Here we have an equation to solve that has a degree of 2. This is a quadratic equation. One option for solving this is to use the quadratic formula. We need to determine what the coefficients of the quadratic equation are in standard form, which this is in standard form, ax squared plus bx plus c, which gives us the values of a, the coefficient on our squared term of 2, the coefficient on our linear term of negative 10, which will give the value of b, and our constant term is c, which is 3. Replacing these variables with the values for this particular equation in the quadratic formula, we have the following. The opposite of b, plus or minus b squared minus 4 times a times c, the entire quantity over 2a. We'll simplify underneath the radical, squaring and multiplying. Squaring negative 10 gives us 100. Multiplying 4 times 2 times 3 is 24. Subtracting leaves a radicand of 76. 76 can be broken into factors of 4 and 19. Since 4 times 19 is 76, the square root of 4 is 2. And to simplify this, we have a common factor in the numerator of 2, factoring out a 2, and then canceling 2 in the numerator and the denominator results in the final simplification for our solution, 1 being 5 plus square root of 19, the quantity over 2, and 5 minus square root of 19, that quantity over 2 for the two solutions.